you remember me from the morning session. If you don't, my name is Anupam. I am a solution architect and consultant here at Relic. And in this session, we are going to deep dive into how you can troubleshoot your entire stack, and not just troubleshoot, how you can basically get to the details of everything. Mean time to understand, mean time to resolution, mean time to detect, how you can get all of that moving with data in context. All right. So first, let's get at it. Let's see how troubleshooting feels like to a developer as of now. Well, maybe this can be a little exaggeration. None of us probably would have 8 screens, but I wish we did, because if we had 8 screens, we could look at all the data all at once, right? But unfortunately, and I'll give you some stats here, on an average, a developer has 25 tabs open on his window, browser window. That's a lot. The problem is, as systems get more complex and we have so much of data coming in from logs, metrics, events, traces across APM, infrastructure, front end, back end and whatnot, this gets overwhelming. And it's not ideal in any sense. And what ends up happening is the solution might come to your head, something like this. Have you felt that? Have you? Okay, very less people. I sure have. And if you have to, I have one good news for you. All of you are in the right session to eliminate this for the good. Here's how we are going to address it. Firstly, we'll cover how Relic is empowering you with not just key quality performance data, but also data in context everywhere. And I'll make sure I bore all of you with the word in context, because that's really the key. Number 2, we will deep dive into how we are leveraging AI to automatically correlate incidents and provide you, again, in context troubleshooting info. Number 3, we are going to cover Relic's modern day take at object-oriented observability using workloads. And of course, we are going to recap everything that we saw during the session. So let's get at it. I really hope the phrase up there really sticks with you even after the session. Data, data everywhere, never a byte to be missed. Because that's what we are trying to do at Relic. The whole vision of the company is based on one simplistic yet extremely powerful idea. And that is to provide every possible byte of data that you ingest into the platform in context to rest of the telemetry. Let's together look how we are already doing that in the platform as of today, which you can use even right now without having to change anything. So the first example we would look at, imagine you're troubleshooting the most critical API your organization has to offer at the most unreasonable hour. At the time, every minute matters, not just to how fast you can go back to sleep, but also to the company in terms of revenue. Every minute directly corresponds to loss in revenue for the company. So what do you do? Usually you begin with looking at APM data. You'll see all the transactions, metrics and all of that, but you're not able to find any clues. Now what would you usually do in that scenario is, of course, you would want to validate. If it's not an application issue, then it must be something related to the infrastructure. You want to validate that. And in order to validate that, the most usual instinctive reaction that we get is probably open a new tab, look at all the hosts where this application is running and see their performance. But opening that tab, searching through those manual hosts takes time. Not anymore with Relic. With Relic, as you now notice, alongside your application data, you have in context infrastructure health data right there. And these are from across your infrastructure components like containers, pods, databases, hosts, and even more. And not just the health information of these components, but on just a single click, you can get to this double clicked version of information where you'll be able to see detailed stats from these components. I've highlighted some of those here, like network stats, detailed process information, and the very innovative key KPI deviation stats. That saves those critical 15 minutes for you to debug your applications. Now imagine a second scenario, just reverse of this. You're trying to triage and troubleshoot your infrastructure. You're not able to get any hints that it could be an infrastructure issue. Of course, you would want to validate now if it's an application issue. Well, no points for guessing. Of course, New Relic has got you covered. This is a snapshot of our infrastructure details page for a particular host, and you have in context application data, of course, with all the key KPIs. When I talk about infrastructure, how could I leave out the all more popular Kubernetes? Here's a snapshot of the very popular New Relic Kubernetes Cluster Explorer, where you have a singular view of the entire cluster's health, and say you are troubleshooting specific pods. I'm sure all of you know how to navigate this, so I'm not going to go into those details. But let's say if you are investigating specific pods, again, for those specific pods, you have in context pod information, container stats, and also application stats. Of course, along with correlated logs as well. So again, you save that extra bit of time in, without having to spend any extra effort and time in trying to identify those correlations. I have a few more examples illustrating the same in context behavior. In this particular case, we have front-end data, of course, with all the key KPIs in context to your back-end application performance. Now, this is the most recent addition from our innovation factory. I did talk about it at length in the morning session. Logs. Logs has always remained a very critical and crucial information for low-level debugging. But unfortunately and sadly, it has also remained the most isolated telemetry. In almost all of your cases, you would have a separate logging product to just look at logs. And that's not ideal at all, because the most value of logs comes when it is in context to rest of your application infrastructure data. Here's a snapshot with our updated APM agents. You'll have log stats automatically available in context to your application performance data. So when you are looking at specific errors, traces, transactions, you know which are the corresponding logs to them. Here's another example of the distributed tracing UI, where you will have multiple entities to serve just a single API call. This is the modern day architecture. And if you had to look at logs from these various entities, again, you would have to spend all of that time. But this is a place where you can really see the power of melt, unleash, metric events, logs, and traces. You have dynamic trace graphs architecturally depicting automatically how your API call goes through, the request flow goes through, with in context event details, in context performance metrics, and in context logs. Now, when we talk about in context data, how can we leave out alerts? Because for your entities reporting to New Relic, you have automatic anomalies rules set on them, which automatically detect anomalies, performance anomalies on them. And you also have manual alerts. So you also have those alerts and anomaly information in context to your application data. And just so that you don't think it's just specific to APM, here's a snapshot of our host screen, where in context to your infrastructure data, we have all the host alerts and host anomalies. All right. So with all of that in context information is how we are providing true observability and eliminating rather data silos. And we have literally personified with those capabilities this statement up there on the screen: data, data everywhere, never ever a byte to be missed. All of the examples which I talked about during the session is still just touching the tip of the eye, just scratching the surface really. Wherever you go in the New Relic platform, our promise to you is to provide you in-context data. Now that we have talked about at length in-context data, I want to switch gears and talk about AI Ops, the second thing I talked about. For all those entities that we saw reporting onto New Relic, all of those will generate alerts, of course, anomalies and alerts as we saw. Now, alerts plus anomalies is in fact those critical signals that we rely upon to notify us when we are not actively looking at screens. And that's where AIOps plays a key role. AIOps helps you in getting those critical alert information automatically correlated into a single issue so that you don't spend that extra bit of time in manually doing that, triaging thousands and hundreds of alerts at a time. And here's how we are doing it. So the New Relic AI engine or applied intelligence will help you get to the root cause of issues faster, as I talked about, by correlating all of these incidents into a single issue. And this is how we are doing it. Basically, it comprises of 4 major components. Number 1, you can ingest alerts from any source, not just New Relic alerts, but you can send, let's say Prometheus, you are using Prometheus alerts to New Relic, CloudWatch alerts to New Relic, or basically any other alert source that you might have. As I said, and as I think Peter also highlighted in the morning, AI is as good as the data that you feed it. So the more type of alert information, the more variety of data that you feed it, the more richer the AI mechanism and the AI algorithm works. So first is ingesting alerts from any source. Number 2, the New Relic AI engine takes care of automatically consolidating those individual incidents into a single issue. Number 3, providing data from all of those entities involved in that single issue automatically in context, so that you do not go through each incident and look at individual data. And lastly, we provide a seamless mechanism to hook this entire workflow to your existing incident management workflows for a seamless communication. So just for example, I've pasted the ServiceNow there, have ServiceNow logo there, but whatever incident management process you would be using, you can very easily configure that with New Relic. So since morning, we have been going through a lot of slides. So let's see this in action now. Live in the product, how does it feel? Yes. So for some integration systems like ServiceNow, Jira, for those you have bidirectional workflows available. Yeah, for sure. We can share it with you post the session. We can do that. All right. So let's look at this in action. So here's the New Relic screen. For leveraging AI Ops, all you have to do is go to this Alerts and AI section. Once you go there, you'll see a section called as Issues and Activities. Basically, here's where you'll have a list of all the active issues and also the past issues that have happened, right? So here's I'm just going to cross out this active one. Let's say I want to look at some historical data. Let me search for a particular service, a particular incident which happened across multiple entities, so that we have a good example to look at. All right, is the internet all good? Just try refresh page. Yep, okay. So I'm going to filter it by the number of incidents that has happened for this particular service. Let's say this is the one I'm interested in. Now this is really, really interesting data. Observe what we are seeing here. Here, this is one single issue. I clicked on a particular issue, right? And this issue was comprised of 16 different incidents. So 16 different alerts or incidents triggered this one issue, right? And you did not have to do anything for this consolidation. The Neuralink AI engine took care of it. So if I just scroll down a little on the page, here you'll see a list of all the incidents which were part of this issue. So you can see it's a perfect example of how rich the AI engine can work if you feed it the right data. So here you have this particular alert from a APM, from a backend application. Here's another incident for error percentage on another application. If I scroll down further, you'll see several incidents on infrastructure. So a very good example of how across your stack, application stack, infrastructure stack, how Neuralink automatically consolidates and correlates these incidents into one. So instead of getting 16 emails and 16 notifications, you get notified once with the right data. If you click on those individual incidents, you'll of course get to look at all the details, when did it happen and all of that. And there's another interesting factor to it. The Neuralink AI engine is not a black box engine. You'll get to see these algorithms. We can chat about it later after the session as well. You can get to see the algorithms behind it and you can get to create your own if you're very interested, right? So you'll see a list of all of those incidents. Then there's this really interesting section called as root cause analysis. So if Neuralink AI engine can figure out what is the probable root cause for this entire issue across 16 different entities, it will give that to you. So in this case, look how fast we can get to the root cause of the issue, right? Here it is saying that the reason for all of these 16 incidents is a deployment that happened on a particular application, which is plan service. And Mr. G. Parker did it, right? So immediately, almost instantaneously, you know what is the root cause of the issue and whom you should reach out or what you should do to fix the issue. Of course, you'll also get data in context. As I promised, I'll bore you with the word in context. So you have log data from across those different entities right here. So if I click on see all logs across your infrastructure and application, you'll be able to see all of the logs just for this incident. If I scroll down further, here's another beautiful view where you have an automatic architectural map created for you. So for these incidents, all the services that were involved, all the infrastructure that were involved, how are those connected to each other? What's the request flow like? So you'll get a view, automatic view into that. So you can immediately pinpoint which is the one, which is the troublemaking service, right? So in this case, I can see billing service is the one as of now, which is having some issues, right? So you can get to the absolute depth of what is causing the whole incident. If I scroll down further, you have a timeline view, not going to go into much detail into that. But here's another interesting section I want to talk about, this analysis summary. As I said, Neuralink AI engine is not a black box and it's open to feedback and you can train the algorithm as well. So here you can provide a thumbs up or a thumbs down on the analysis that the Neuralink AI engine provided you, and based on your feedback, it will continuously learn and improve based on your feedbacks. There's one last section which I wanted to walk you through, and that is post-mortem. This is something that I've observed in large enterprise customers almost being a mandate, right? So for the incidents, major incidents that happened and it caused some trouble to your business and loss of revenue, there's always a mandate to maintain a historic record of that. So it was always done outside Neuralink before this. So we very recently launched this feature called as post-mortem, wherein you can maintain a detail of historic outages on your systems. So you'll see for this incident, there were 16 different alerts involved. So the details of all the alerts are here. The details of all the entities are here. You can also add your own information like specific to your organization, right? So you can add all of those information here. What was the root cause? What were the recovery actions? How did you go about it? So you can add all of those details and create a post-mortem, right? So even after the incident was resolved, what did you do to, to solve the issue and all of that information gets maintained and stored within New Relic. So if I go back to the issues tab, you'll see there is a post-mortem section which has all of those details. So again, a very useful feature. So that is what AI Ops was all about. Let me move on to the next one. Workloads. Why is this important? So firstly, just a quick recap, what we saw is how you can get in-context data with New Relic, everywhere in the platform literally. We then saw how you can use AI Ops to automatically correlate incidents and issues into one, using the New Relic AI engine, saving those extra bit of time. And of course, a combination of both will help you smash down the mean time to resolution, which is good, which is really good. But there's still a key piece to the puzzle that's missing. And that is, how do we bring down mean time to detect and mean time to understand? And that's what we are addressing with workloads. Let's understand this even better with a common world example. Now imagine this is what your closet would look like. Frankly, I don't have to imagine. My closet more or less looks the same every day. But you can imagine. In this closet, you have all the right mix of clothes, probably everything that you would, that you would ever need for any occasion, right? But let's say for a particular event, future stack, you wanted to wear a black hoodie, right? And in order for you to find that black hoodie, you would have to go through all of that junk. You have to go through several clothes, probably throw around a few more, and then you would get to your favorite black hoodie. But what if your closet instead looks something like this? If it did, well, almost immediately you will get to what you were looking for, right? And it would save you so much more time. Now that's what we are doing with workloads. So no observability or basically any vendor out there in the market can on its own understand how your organization functions. You know it the best. Every organization will have multiple complex combination of entities and teams working on different projects to deliver results, right? You know it the best. We know a lot of companies who function, who probably function in the same domain but still work and organize very different to each other. Each company will have different teams working on different projects, different set of responsibilities, and that's where workload really plays an important role. Similar to in the closet example, in your wardrobe, let's say you can arrange your clothes based on their utility, or you can arrange your clothes based on how you would want to use them, like rough use, fair use, outside use, whatever. Similar to that, using workloads, you can group your entities based on how your teams function, which teams are responsible to manage those entities, or simply by those type of entities itself. So in summary, and we'll see a live demo of workloads as well. In summary, what workloads really empowers you to do is create very seamlessly group of entities based on how the teams manage them, how they function, isolate the source of a problem really quickly, and resolve incidents faster because you get to understand and you get to detect them better than ever before. And one last thing, which is not related to the utility of workloads itself, but the creation. If you are thinking that you would have to spend a lot of time in creating these workloads and getting all of those views, well, you do not. If you are maintaining some sort of hygiene in your observability using those tags, you can get those created almost instantaneously. And we'll see that live in action now. So let's move back to our platform and see how we can immediately start with workloads. So if you go to New Relic, you'll find workloads in this left side nav bar. All you have to do is just click on workloads. As soon as you do, you'll see workloads. Basically, you can see workloads from all the various accounts that you have access to. Okay. So here I have workloads from all the accounts, all the workloads you can see, but you can choose to see workloads from specific accounts or use a filter. By default, you have a health stat view, right, of all the workloads. Now imagine this. If you're in an organization Very simple example. You have 5 teams, one database team, one application team, one front-end team, one mobile team, and probably another, some external like operations team, right? Each of those manage their own set of entities. As soon as you come to this view, you'll see what the health of those workloads are, which are the teams whose entities are being impacted. And even for individual engineers within those groups can immediately get to their own set of entities without having to go through all the other data that is available out there. So you'll have that view, but if you are doing it for the first time, you simply have to click on this button, create a workload, which will help you create a workload, and it's extremely seamless process. So you can just give a name. Let's say I give Future Stack India Bangalore, something like that, and you can select the account in which you want to create the workload. If you filter down, you can see there's this filter icon which you can use, and this is the one I was talking about. If you have existing tags, you can use them to immediately create spin-up workloads, right? So I'll use one of the tags called as KTS cluster name. So if your tags do exist in your account, and if you have a good internet connection, unlike I do at the moment, you can get those tags immediately. And if you select on those tags, you can basically use all the operators. I can select, let's say, cluster name equal to, and then let's say I want to select all the entities which have this tag. So I can select that, and all the entities which do have this tag will pop up right here. So I can just scroll you and show. So this will be a combination of containers, pods, applications in this case. In your case, it could be specific things which have those tags. So you can individually add these entities here if you want to look at only specific entities in the workloads, or what you can do is you can simply click on add this query, and all the entities involved will automatically get added. And basically that's it. That's just it. And you can just, create the workload as is. So I'm not going to create, since it will be a duplicate. I'll go into one which I have created already. So let's say I want to look at, let's look at this one. Okay, so we have a variety of entities here. So once you click on a particular workload, you'll see everything that is present within that workload. If you go to the service levels, this is one really important section. So here, whatever SLAs that you have defined, and service level management has been a key concept within a lot of organizations. So all the SLAs that you have defined for any of those entities involved in those workloads will appear right here. You can click on specific entities and SLAs, and it will give you all the detailed views. If you go to the activity section, you'll have again all data in context. So here I have a bunch of APM applications, backend services. If I scroll down, you'll have all the Lambda functions. So everything which match this tag is existing right here. Again, all in context. So specific teams can look at only the information that is relevant to them. There's one another important view, which is this map view. So basically, if you have different set of entities which are talking to each other, it will automatically map them across the stack. So the UI layer, the service layer, the backend infrastructure layer, however is the communication going on, it will automatically map it out for you. So that's how you can use workloads to basically get to the incidents faster than ever before. Now, just summarizing everything that we saw during the session, firstly, we saw how you can leverage in-context data to basically everywhere in the platform to get instant access to the right correlated information to troubleshoot your issues. Next, we saw how you can use Relic AI capabilities out of the box to get automatically correlated incidents into a single issue with, again, in-context troubleshooting info. And lastly, we saw how you can use workloads to detect and understand issues and maintain a good hygiene practice in terms of observability to smash down the mean time to understand and the mean time to detect those incidents. Now, I urge all of you to use all of those functionalities that we just talked about within the tool, and I promise you'll never feel like smashing the screen again like we saw earlier, but rather you'll feel something like this. Loving your laptops and loving your screens. That's my time, guys. Thank you for listening to me. I hope you enjoyed the session.